This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Okay, welcome back for another lecture of construction history. In this one, we will introduce some of the first and most important concepts that will lead us into modern architecture, modernity, the present, and we will do so by going to Chicago. As you must be surely aware, Chicago is famous for a school of architecture, the Chicago School, that developed in the late 1800s as a result of a convergence of technological and economic developments that created the conditions, as many recognize, for if not for the first, certainly for some of the most important new building typologies that are often referred as skyscrapers. Of course, Chicago is only one city in other centers that develop high-rise and multi-story construction in the United States. Of course, New York was also at the forefront of that. But we will talk about Chicago in particular because more important, in effect, than the idea of a skyscraper, Chicago is important because, from a technological perspective, is the place that where it is possible to observe an evolution of construction systems that eventually will take the form of what we today recognize as the skeleton frames. Now, skeleton frames, skeleton buildings are still obviously very important today. And so it is very useful, I suppose, to understand how we got to this point and how we developed these technologies that we continue to use. As we will see, this is a gradual process, so we'll see how the technique of skeleton frames didn't happen overnight, but it actually was a part of a continuous step-by-step evolution that eventually took us to a freestanding, standalone structural system of steel, which is normally what is referred to for skeleton frames. So we'll start talking about what's normally in the literature of history of technology or history of architecture for this period. You may hear the term of caged frames, or which is a word that describes a hybrid system, hence my preference to define it as hybrid cages. And you would have heard that Chicago is the home of the birth of a skyscraper, particularly because of this building, the Home Insurance Building, which a building that was designed by William Le Baron Jenney in mid 1880s. Often there is some sort of cliches that are presented about this building. It is often forgotten that this was a building that was developed in two stages. First for 7-story multi-story building that eventually had another 3 stories added later on. Now, to get to the point of this, the bottom line is that ultimately there's no such thing as a first skyscraper. It's the label itself of a skyscraper is quite slippery. It's very difficult to define what is a skyscraper in reality. But generally, in the tradition of historiography of architecture, there has been a simplification that for which skyscrapers were born with this building, because this building used steel and allegedly a skeleton frame. However, looking more closely at this building, the Home Insurance Building, you will recognize that in reality, yes, there is a framing system that it's clearly recognized from this plan inside. You can see some of the characteristics of what we would recognize as tall buildings still today. So we see lifts here, all arranged in a bank, and we will see a series of columns that are obviously receiving beams and framing the interior of a building as a skeleton. However, if you look closely around the perimeter of the building, you will find how the external columns are in effect buried inside a masonry pier. So more precisely, and this wonderful reconstruction here by Tom Leslie, a professor at Iowa State in the United States, shows how there's a composite almost approach where you have a cast iron column that is embedded in a pier of concrete, and then this cast iron column is supported some steel girders, which in turn support a floor system of terracotta tiles. So this is not quite the skeleton frame as we know it today, and you can see in this historical picture here on the right how clearly the cast iron column is embedded inside the concrete. Now, you probably would argue, yes, but concrete is there just to fireproof the column. Well, not really, because actually the weight of the concrete surrounding is giving also more strength to the external frame of the building. Tall buildings are like vertical cantilevers. They need to be stiff and rigid as well. And cast iron, as we know, is not a material that is very good in bending, and it's subject to failures if exposed to significant to buckling, for example. So the pier around the cast iron columns is actually somehow reinforcing also the column, preventing it from buckling, and also adding additional weight to resist the wind. Nonetheless, this is a first step in a sequence of buildings of which certainly Le Barogeni was at the forefront. And in fact, we will probably recognize some of the principles of skeleton frame more in buildings that are less known in the actual home insurance building, or less celebrated, I should say, than the home insurance building, in particular in department stores. So you can see this building here, which has been demolished in Chicago, which is actually antecedent to the home insurance building, where you can recognize more clearly this sort of skeleton approach. Probably the commercial pressures that need to be very pragmatic with these buildings induce the architect, or architect engineer in this case, Jenny, to reveal the structure in a more direct way than in some of the commercial buildings that have a bit of more of a dress to attract tenants. And you can recognize this approach here, where suddenly we actually see the columns that are, yes, not quite embedded, protected by a wall on the outside. So they are engaged with an external shell of masonry, which is helping the building to be stabilized. And then a series of cast iron columns again that are obviously providing support for girders, and then from girders there will be secondary beams. This is a department store. It's not a tall building. It's not a skyscraper. It's a building that is wider than it is taller. But nonetheless, the skeleton frame is starting to take shape, combined with this external shell of masonry that gives more weight and more lateral stability to the building overall. Now, the reason why really we cannot talk about skeleton systems in full in these first examples is because very often the columns are cast iron columns. Cast iron is a material that is good in compression, but not so good in tension as you would think. Not all iron is good like steel today, that is both just as good in compression as it is in tension. Cast iron is brittle. It tends to fail quite unpredictably. A bit like glass in a certain sense. It tends to snap. It cannot be welded. It cannot be modified on site. It cannot be perforated for the properties of the material itself. And so very often we see cast iron columns that support beams, but they do so by having very simple pin connection, very often supported by a little shoe, a little leg that is part of the cast iron column itself. So in this sense, they are not the frames that we would expect normally today. You can see in these other details here how two cast iron columns come together by splicing each other by using bolts. They're not welded. The connections are not necessarily continuous. They will be prone to imprecisions on site. unless and there will be some elements of tolerance that will make these pin connections quite loose, and therefore they don't have the rigidity and the continuity of structure that we would normally expect, particularly in a high building where a certain amount of stiffness is required to prevent the building to move too much, or if not to catastrophically come down as a result of an excess of overturning on the structure. And we can see again this tendency to combine an external masonry shell or cage with an internal arrangement of freestanding columns of iron, often combining iron and steel, but most often using cast iron as the primary element of the structure. And we can see this repeated in some of the best examples of the period, like the Rookery building, one of the most prestigious commercial buildings in Chicago during the 1880s. And again, you can recognize here a very deliberate approach of relying on masonry to somehow stiffen the building and give it some stability and weight on the outside. This is what probably referred as a neo-Romanesque building, and you can recognize here very clearly the piers terminating with this sort of revival of classic forms that are combined with some cast iron spandrel beams that connect together the piers also horizontally. But ultimately, there is some elements of change that are happening, that are visible in particular in the Rookery at the back of the building, where at the base of the structure suddenly the masonry becomes it just sort of disappears, and it transitions into this cast iron shop front in a laneway at the back of the building. Some of the lightness of the internal structure of the building is also visible from a light court that is inside the building. A light court that was also covered with glass, and that was also refurbished in the early 1900s by Frank Lloyd Wright, of which you can probably recognize some of the characteristic elements of Wright's design in this wonderful filigreed arcade. And Wright actually worked for Burnham, one of the architects of this building, alongside with John Root, and he was able to actually intervene in the building without really altering the initial principles too much. And this sort of tendency towards lightness of envelopes become much more evident, particularly inside in the walls of a light court, that somehow anticipates what you would recognize as a curtain wall, or a lightweight system that is like a covering the structure, but not necessarily working also as the structure like you would normally expect in a masonry building. So this is some examples of a series of buildings that in Chicago happened, particularly between the early 1880s until the end of the same years, and as you can see, there's the dominance still of masonry as the principal material that helps multi-story buildings to resist lateral displacement or the force of the wind. But something happens during the 1890s, or at the transition between the 1880s and the 1890s, where we start to see buildings that take this some of these ideas of the steel or iron frames inside the building to another level. In other words, there is an understanding of the structural challenge of a tall building that requires some bracing elements. There's a building that is certainly very, very significant in this transition, and that is the Monadnock building, which again uses masonry to a great extent, but it pushes almost the limit of masonry for a multi-story structure. And you can recognize this building, how it's somehow tapering from the base to the top, particularly in this very dramatic view, where the external skeleton of the building is masonry. In addition to that, there are some shear walls that are helping the structure to be stabilized. But internally, again, we see to reappear the lightweight columns of cast iron or steel combined together. We see the approach also of having, in this case, two lift cores here, or two lift banks side by side next to the stairs that provide circulation. But certainly there is now, again, masonry that has been used to its maximum by using a tapering on the structure outside, as well as this very noticeable shear walls inside. So the monadnock is probably the ultimate masonry skyscraper in a certain sense. But it is also a building that has a core or an internal soul or of steel and cast iron. So you can see again in this digital reconstruction, like the masonry is somehow working again in a combined fashion with steel. But most of all, it's also making an acknowledgement here of the lateral forces that are working on this building by a very noticeable braced walls and some braced frames that bridge from one side to the other. At the base of the building, on the other hand, or the external skin of the building, we have this enlargement at the base that takes almost Egyptian proportions, where these walls are straight on the inside, but they taper out, they bulge out at the foot, on the street level, and becoming a most recognizable feature of the building. And you can see here in this section clearly how these external walls are expanding and enlarging themselves at the base. And you will recognize here how the internal structure, on the other hand, is still lighter. It's iron, it's steel. It is basically a skeleton, semi-skeleton structure that is distributing its load also on the ground using this very characteristic foundation that was developed in Chicago in the same years. A grillage foundation of steel beams or rails that are superimposed and they sort of create a pyramidal arrangement that spreads the concentrated load of the columns progressively onto a larger area and then eventually onto a concrete footing. Now, this was very important for a city like Chicago, which, unlike New York, that sits on a fairly shallow bedrock, relatively shallow. Chicago had a bedrock that was much deeper than that. So very often these buildings had to rely on a soil that was clay, that didn't have the same bearing capacity that you would find in rock, and therefore there was an additional need to spread out these buildings using this technique of using rails of steel superimposed onto one another. And this would be the arrangement of buildings that were relying on this steel pierced, sort of coming down to a series of steel beams or girders laid out horizontally in layers and crisscrossing each layer with the next one below, so that all the loads eventually can spread out more efficiently. But there's other developments that take shape, particularly in the bracing strategies of the architects in Chicago. And again, we see a building on Burnham and Root, the same architects of the Monadnock here, designing in the Masonic Temple, a building that was demolished in the 1900s, where suddenly we still see, yes, the masonry cage on the outside, but in the internal steel framing, that it's using braced frames. So you see these crisscross patterns here in between the columns along one of the edges, and even almost on a floor basis, and then even more so on the other side of the building when you have crisscrossing or crossed brace frames for two stories at the same time. And you can see a similar approach also in this other building, more or less in the same years. This one designed instead by Holabird and Roche, other architects still very successful and at the forefront of these developments in Chicago, where, yes, again, you see a shell, an external skin of bricks here, in this case, not so much neo-Romanesque, but almost neoclassical, particularly at the top. A fairly austere brick piers and horizontal structures of brick on the outside, that it's probably, in a certain sense, even anticipating modernism as a language. But ultimately, it is a building that is still transitioning, and it's doing so by using these very interesting portal frames. So you see again here in the plane quite clearly you have a steel frame or a combination of steel and cast iron, and these portal frames that are located in this position. The columns being embedded inside masonry again. You see some pure masonry mullion columns in between, and the building is stiffened, being a rectangular plan here, with a wall shared here with another property, and these wonderful bay windows here on the corners that are, semi-circular, to give more light to the deeper sort of sides of the floor plate. But you see in this location that I've highlighted, there are some braced frames. There are portal frames, very large portal frames with this segmented arch profile that are cutting through the floor plate, and they are located on both sides of a central corridor containing the lifts and circulation of the building. These are steel plates that are riveted together, so very laborious technique that is putting together steel profiles to provide stability to the structure laterally. And you can see how the foot of the building is still employing the typical Chicago steel rail foundations. But there's another development, again, same here, again, Holabird and Roche, same architect of the building we just saw, the old colony, where they sort of recover some of the elements of the monadnock. So we see now to reappear, yes, these shear walls, but instead of using the large steel and riveted veering deal approach almost of these internal walls, they use masonry in this building at Tacoma. And they do so by freeing up again the perimeter of the building to use these bay windows as a continuous frontage, so providing more light inside. So we start to see now the structure on the outside working independently, but it's still in combination with masonry to provide stability. And you can see here again in this very nice reconstruction in 3D how all these elements come together. So this is probably one of the first genuine curtain walls, in the sense that the external facade is, although not necessarily suspended, it would have an element of self-support and certainly also an element of protection. But it's an external masonry skin that is relatively shallow, that is not doing any work to stiffen the build laterally. There's metal frames here that are doing that work, but masonry is becoming an element of bracing that it's embedded inside the structure. But developments also happen not necessarily in this multi-story building, but very often in buildings that are not necessarily as tall. And particularly, again, going back to the department store, we see how Le Baron-Jenny continues to take this concept further, to the point that we start to see here in 1890, 1891, we start to see the first pure steel frames all around, where you have riveted profiles of steel combined with combining columns and beams to provide very large spanning elements. That building we just saw before, the first store, does not survive anymore, but we can see some of this technique in Le Baron-Jenny in this building. It still survives, fortunately, in Chicago, the second lighter building. You can see again a department store, not necessarily a skyscraper, a multi-story warehouse type of construction, where you see how the skeleton, the framing of the structure is expressed almost on the outside, also visually. And you can see here some of it is even expressed directly particularly of the ground floor, where we have very large transfer beams. You can recognize here the rivets that reveal the technology here of the steel girders coming together. So what is happening is that suddenly steel is becoming more accessible in Chicago. And the steel of those days is not the same standardized steel that we have today. It's a steel that is, yes, steel, so it has, that composition and the properties of the material that we are familiar with today. But it's often steel that is using rolled shapes like channels or plates or angles, and then combining them together by using rivets to create more complex and more able to resist and stronger sections. So you can see here some examples of columns that were available in those days, where you have, for example, two channels side by side connected by a series of plates riveted to the flanges of the channels, or a combination of those with some plates that connect channels together, or two channels back to back here connected by an external plate on the outside, or a simple I-beam here, an I profile, combined with two channels on the riveted through the flanges on both sides. So this configuration now create opportunities to connect these columns to beams and create entire skeletons of steel that are now eliminating cast iron, the unreliable, brittle, and somehow incomplete performance of cast iron. It's ruled out of the picture. Wrought iron also was used very often in these buildings, but as we know, wrought iron was a fairly laborious metal to work with and to produce. Suddenly steel displaces this material and can become a standalone material that is easy to fabricate, easy to adjust on site if needed, and also easier to design with because from a structural perspective it performs both in compression and in tension in an equal manner. And so at this point, this is when finally in the early 1890s we start to see the first true skyscrapers, perhaps the first true standalone pure skeleton buildings, in the same way that we would recognize them today as multi-story buildings. So arguably, if there was any first skyscraper, it's probably one of the ones that I'm showing next, although it would be difficult to pinpoint just one builder rather than another. The Reliance building certainly responds, again, another building designed by Daniel Barnum, former, a colleague of Root by this time, had passed away. And this building certainly incorporates those elements of the steel frame clad by a lightweight facade all around. And it does so much more than, for example, the home insurance building that is often, a bit hastily, pointed as the first skyscraper in history. But it does so because when you're looking at the plan of this building, this is the contemporary plan, if not the original plan of the Reliance building, you can see that there is no internal shear walls. And at the same time, there is no external masonry walls. Yes, there is a wall here, and another one here on the other side, but those are walls that define the perimeter of the property. In this sense, perhaps the Reliance building is not truly the standalone freestanding skyscrapers yet, because this wall certainly would have also played a role in helping the building. But you can see how along these walls there are some columns that are supporting the building. A bit less on this side, but certainly you can see how the perimeter of the building has got these bay windows, and you recognize now there is a series of columns here that are just standalone, supporting girders and secondary beams throughout. And this is a picture of the building going up. You can see how the building is able to stand alone without needing any help from the side walls in masonry. You can recognize here some of the steel beam profiles being composite or different raw profile. You can see some craning elements here, and you can recognize that this is a very common approach that we take for granted today, of a steel frame going up first, some steel mullions coming to follow to shape the facade, and then the building continuing up on its own, eventually having the steel to top the structure, whilst the concrete slabs will start to follow up below, and then eventually the building is completed. So this is an interesting building in a sense that it anticipates, or it probably condenses for the first time, this ability to build a structure standalone without having to rely on heavy materials like masonry to stabilize it. But there's another interesting part of this building, and it's its facade. There's a lot of glass. This is plate glass produced industrially on a large scale, large sheets. But it is also a facade of enameled terracotta. So terracotta, it was used very often as a material to fireproof columns. We'll come back on this a bit more in detail later on. But in this case, terracotta is also used as a cladding, and it's enameled because the enamel gives it an additional ability to be durable. And you can also recognize how the structure in this case is using some of those profiles we saw before. In particular, here the Reliance building is using a very particular configuration, which is known as the grey column, a column that is formed by angles of steel. You can see here the angles back to back, riveted together, and these angles are organized in a cruciform fashion, so they're riveted together, and then they have these bent plates that connect 4 sets of these angles riveted together, creating a cruciform plane. And why is that? Well, there's some benefits for connection, because it becomes a very convenient shape to turn corners, for example, in a building. But also it allows to be used in multi-story construction in a very convenient way. So if you imagine this to be a typical column from the top of the building, at the base of the building you might want to have a column that builds up from that by adding additional steel plates that you can see in this position here. In fact, there is 3 plates that are stacked sort of on top of one another and connected back to the angles that form the grey column. Why is this important? This is important because it allows the column to increase its section from the top of the building to the base of the building. The loads in a multi-story building increase when you go from the top to the base of the building, and so this is a very convenient shape that allows you to build up and vary the section of the columns as you go, of course, high up vertically. And again, this is a wonderful picture of this wonderful building here, where you can see this terracottas used to clad the building throughout. You can see here also these very large expanses of glass, the bay windows, and how the entire building is relying on this combination of glass, terracotta, and a steel frame behind. So you can see here the grey column. We can recognize now the 2 angles kept together by the rivets and these bent plates, and then you can see how the beams here of the frame connect into this the grey column internally. At the same time also provide support to run an external spandrel beam that can be used to support the terracotta cladding. So you see the grey column now has been here in this view. This is the final architectural details embedded inside a terracotta mullion that defines the corner of the building, and also helps to house the windows. These are sections of the same detail. You can see here on the right just the structure of steel, where you can recognize here a girder. You can see how the girder as well is combining angles that are riveted together, and then there's a plate that is working like a flange. You can see some rivets in the background, other plates that connect to, and you can see here there's an angle profile, or two angles back to back, that become the support for a brick spandrel. A brick spandrel here just for fireproofing purposes, and then on the outside you can recognize these terracotta profiles that are the finish of the building. Enamel terracotta, as we said. And again, these are some views of the steel framing, how it's all coming together. You have the grey columns here, the terracotta external skin defining the bay windows, and this is a view of the steelwork below that gives you an explanation of the configuration. You have the grey columns again, and in these positions here, and then you have an edge, a beam that's sort of running in between these two, from which you have some cantilever brackets that support the bay window. And you can see here this section here, and an external view of the bay window. You have the enamel terracotta spandrels just defining each floor. There's some smaller mullions also clad in terracotta, large plate glass fixed, some operable smaller windows in between in the bay window. And again, all this is supported by these brackets of steel that are riveted back together onto this edge girders that are running past along the lines of the other spandrels. Now, this was not just the only building in those years that was using these techniques. There's another very elegant building in Chicago known as the Marquette, more or less built in the same years, that it's using a very similar approach. This is Olabert and Roche again. So there's no such thing as a first. This was all happening at the same time. You can recognize now clearly the approach where you see much more glass. You can see this neoclassic sort of cornice at the top of the building, and you can see a clear expression here of the structure, which was steel again, and some horizontal members and terracotta that continues and completes the building, and it clads it and gives it this very elegant neoclassical look. So you can see here a detail of the spandrel. You see again a steel girder, and you can see how there's another channel of steel that is used to support the terracotta cladding, which is the one you can see here in this position. But perhaps one of the buildings that really took this concept to the final stage is the Fisher building. A building that often in architectural history is a bit snubbed off because of its decorative envelope, but a building that certainly demonstrated possibly only a year later after the Reliance, after all, so more or less in the same period, it certainly demonstrated not only the approach and the validity of this principle, but also it showed how fast the steel structures could be put together. Now you recognize here on the plan the approach of a skeleton structure. You can see the columns. These are steel columns. You can see a series of primary beams that will be spanning in between, and also edge beams in between the columns that would be used to support some secondary beams, and again brackets to launch outside of the skeleton line to support bay windows, so to provide more light, a lightweight skin all around, a bank of lifts, almost like a core, I would say, an end core kind of configuration at the back of a building. Three sides, freestanding, a party wall with an adjoining property that will be eventually developed by the same owners of this building, with an extension of this using more or less the same architectural treatment of the Fisher building of the first stage. And this is the Fisher building today. Okay, wonderful building. just taking on board the same language of lightweight, almost filigree structure, where you have columns, horizontal elements, often some columns expressed, some mullions sort of introduced in between to provide a suitable break for fenestration or subdivision into rooms for offices, then bay windows, and then a cornice normally terminating with semicircular arches, so again borrowing a bit from the neo-Romanesque, and then a cornice at the top. This is also some pictures of the building under construction. You can see how everything is still, including on the ground, including down to the foundations, as we saw very often. And then a series of columns going up, starting to prepare the work from the floors above. You can see some derricks there, or cranes in the background there. And you can see how the building starts to take shape over the ground floor, with a series of horizontal beams now supported by the columns. And you see the second level here already formed, and then the third one starting to take place. And again, continuing up, you can recognize this sort of built up steel sections. You can see it is steel throughout. The date here is November 1895. Construction started in October, early October of 1895. And by the time it was the end of November, the whole steel structure was completed. So 2 months to put together a building that today will probably take almost, at least 6 months. Very fast construction, very different labor conditions in those days. But this is a very telling picture that is telling you how the entire structure, yes, it's steel, but you can also see how, for the first time, we start to appreciate this idea of a building that is being layered vertically as you go up, like we do today. You see the skeleton is already in place. You see a platform here on the edge that is used to install a terracotta facade. And then you see that the glazing and the finishing on the building is starting to take place. And all this can happen almost irrelevant of the work that will happen on the ground. So you can almost bypass in this way whatever might be the more laborious or the more delicate work that often happens at the ground floor. It can be finished later. Again, this is what we still do today whenever we can. And this is a final view of the building here. You can see in this very, telling contemporary postcard, where you have the building standing up, completely freestanding, also in front of the famous, elevated railways of Chicago. And when you look closely at this building, you recognize this decorative approach. So it is a building that is often, the Chicago School is often, pointed as the beginning of modernism, but in reality, the Chicago architects of those years were actually quite keen to ornate their buildings and use decorations. In this case, using terracotta. Terracotta used to provide spandrels, to provide continuously from the typical bay to the bay windows, but also to provide cover for mullions. And this is a close-up of the Fisher building at the point where it sort of adjoins the property that was expanded later on. So this is stage number 1, and here is stage number 2. You can see how there was a system that was also able to be repeated and picked up again in the future. And the system was due to the fact that there was a very generous use of terracotta, enamel terracotta that was able to withstand the terrible excursions of temperatures of a city like Chicago. But it was also produced in an industrial way, but not necessarily to the extent that there would be off-the-shelf products. Very often these architects were the ones who would feed decorative patterns specific for their projects, but then they would be able to use them at large scale. So the large scales of the project often gave some buy-in to these companies that produce terracotta for mass production, but also allow architects to somehow participate into the mass production process. So we'll come back on this idea of terracotta, because this is just the first part of a series of lectures that will explore this period in history, but also how this is somehow the first and the setting stone of many developments that we can also observe in other cities of the world. We can observe similar patterns, of course, in New York, but with a very specific local difference. And we will see how some of these technologies and trends become very relevant also for Australia. Not much later than in this period in Chicago. So I'll leave you here. As usual, you will find there will be material on LMS, and so until then, take care.